Welcome back to my YouTube channel. So we are still on partial differential equation. So now we're going to be treating how to form partial differential equation from ordinary functions, right? So this is actually different different because we have been trying to solve partial differential equation using separation of variable, wave equation, heat equation. So now I want to see how to get or derive a partial differential equation from ordinary functions. So now there are two ways of doing that. Either we can eliminate the constant, or we can eliminate the function. So that there are basically two methods. So this is by elimination of arbitrary constant, and this is by elimination of arbitrary function. So now I want to see how to form a partial differential equation by eliminating arbitrary constant. Now, what is a constant? Constant is just basically you can take the value of any numbers, right? So if you look at this equation below, if you look at this equation below here, you are seeing x squared, y squared, z minus c. This here is a constant, and this here is a constant. So c and a are both constants. So now, in order to form a partial differential equation, we need to eliminate c, this constant c. But now, if you look at this partial differential equation, we are having three variables. We are having x, y, and z. So now, how do we solve it? So now, first, in forming partial differential equation, we tend to assume. Now, we assume that let p be equal to dz dx, and let q be equal to dz dy. When forming partial differential equation, we tend to put this at the back of our head. So now, given this equation, like I said, let's take forming partial differential equation by elimination of arbitrary constant. So now, let's solve this equation. So we are having, we were asked to find, or we are asked to form the partial differential equation from this equation. So this is xy plus y squared plus z minus c squared equals a squared. So now, if you look at this, there are no functions, they are only constants, right? So we use the method of elimination of arbitrary constants. So now the first thing we do, since we've said let's assume dz and dx to be p, and let's assume q to be dz dy. So now let's differentiate this. So let's differentiate it with respect to x, right? Now we assume that z is a function of x and y, right? So we assume that z is a function of x and y. So we assume dz dx, let's call it p, and dz dy, let's call it q. So now, differentiating this equation with respect to x, so this will be 2x, right? Now, differentiating with respect to x means that all other constants is 0. If I'm differentiating an equation with respect to x and there is y will be taken as a constant. So differentiating y is 0. So this will be 0. Right. So plus, now I'm having my dependent variable, which is z. So remember, if I'm differentiating an implicit function and my dependent variable is there, so once I differentiate that dependent variable, I'll multiply it by my derivative, the derivative of that variable with respect to what I'm differentiating with. So since this is my dependent variable, so differentiating this now, this will be 2z minus c, right? And since that is my dependent variable, I'll multiply it to the derivative with respect to what I'm differentiating with. That's dz dx equals a squared. Differentiating a squared is a constant, so I have 0. Right. So I'm left with 2x plus 2z minus c dz dx equals 0. So since so now let's take 2x to the other side. Or yeah, let's take 2x to the other side. So this is 2z minus c dz dx equals minus 2x, right? Right. So 2 can cancel 2. So z minus c dz dx equals minus x. So now let's simply call this one equation 1. So now we're going to differentiate with respect to y. So we've differentiated with respect to x. So now let's differentiate with respect to y. So bringing back this equation, so this is x squared plus y squared plus z minus c squared equals a squared. Right. So differentiating with respect to y now. So once I'm differentiating with respect to y, x is constant. Remember, I'm differentiating with respect to x and y because my dependent variable is a function of two independent variables, because we are talking of partial differential equation, which is exactly what we are talking of, where we have two independent variables. So I have two independent variables, x and y, and we have z, which is a dependent variable. So I've differentiated with respect to x. Let me differentiate with respect to y. So differentiating with respect to y, so since we have differentiated with respect to y, x is constant, so this is 0 plus 2y plus, since this is my dependent variable, differentiating my dependent variable, this will be 2z minus c, multiplying it by the derivative of what I'm differentiating with respect to what? Y, right? Equals 0. A is a constant, so that's 0. So this will be 2z minus c times dz dy equals minus 2y, right? So 2, we cancel out 2. So z minus c times dz dy equals minus y. So we're having a second equation 2. So now, remember, for us to form a decent partial differential equation, I have to eliminate this c, or technically I have to eliminate this whole thing here. So in order to eliminate it, so now let's make the z subject of formula. I think that's the best way you grab it faster. So making the z subject of formula, of course, since we said p is equal to dz dx, right, and q is equal to dz dy, so now let's just replace it. So this is z minus c, replacing equation 1. So this is p equals minus x, and equation 2 goes z minus c, q equals minus y. So making the z minus c subject of formula, so this is z minus c equals minus x over p. Making z minus c a subject of formula, this is minus y over q. So equating the two equations, because this is z minus c equals minus x over p, and making z minus c subject of formula, this is minus y over p, right? So equating the two equations, so this is minus x over p equals minus y over p. So minus will cancel minus, so I'm left with minus y over q. So I'm left with qx equals py. Or you can say dividing both sides by q, or just turning it into a fraction. This is dividing both sides by q and dividing both sides by y. So p over q is equal to x over y. So this is the PDE with respect to, this is formation of PDE by elimination of arbitrary constant. So this right here is our answer. So in the next video, we'll look at how to form partial differential equation by elimination of arbitrary function. Thanks for watching. See you on the next video.